Rising seas are quietly rewriting the map of our planet, and Sentinel-6B has just been launched to track every centimeter of that change. Sentinel-6B, part of the Copernicus Earth Observation Program, is the newest satellite dedicated to measuring the height of the world's oceans with extraordinary precision so scientists can better understand climate change and improve ocean and coastal forecasting. A new guardian of the oceans. The satellite is often described as a new guardian of the oceans because its main job is to keep a continuous, highly accurate watch on global sea level, one of the clearest indicators that the climate is warming. Like a relay runner taking the baton, Sentinel-6B picks up from earlier missions so that the long-term record of sea surface height remains unbroken, which is essential for spotting subtle trends over decades rather than just short-term ups and downs. Launch details and first contact. Sentinel-6B blasted off on November 17, 2025 at 6:21 Central European Time aboard a SpaceX Falcon 9 rocket from Vandenberg Space Force Base in California, a site commonly used for polar orbiting Earth observation missions. Less than an hour later, the satellite was placed into its intended orbit, and at 7:54 Central European Time ESA's European Space Operations Center in Germany received the first status signal via the Inuvik ground station in Canada, confirming that the spacecraft was functioning as expected. Building on a long legacy, Sentinel-6B continues the work of Sentinel-6 Michael Freilich, which was launched in November 2020 and itself extended a sea level record that began in the early 1990s. The chain started with the French-US Topax Poseidon mission and then the JASON series of satellites, creating a multi-decade timeline that climate scientists rely on as the global reference for satellite-based sea surface height measurements. Why this mission matters now? With sea level rise now a central concern for governments, insurers, and coastal communities, Sentinel-6 has been developed as the gold standard reference for sea level monitoring, aiming to provide more accurate and stable measurements than any previous mission. These data underpin climate reports, risk assessments, and long-term planning for the millions of people living near coasts or in low-lying areas that could be affected by storm surges and chronic flooding. A truly international partnership. Although Sentinel-6 sits within the European Union's Copernicus family of missions, it is the result of a large international collaboration that brings together the European Commission, ESA, NASA, Eumetsat, and NOAA, with additional support from the French space agency Nice. This broad partnership pools funding, technical expertise, and ground infrastructure, raising an interesting question: should global climate-critical data like this always be managed by international coalitions rather than individual nations? Leadership views and a bold claim. ESA's Director of Earth Observation Programs, Simonetta Celli, has emphasized that close cooperation between agencies and industry partners is fundamental to a complex mission like Sentinel-6, from design and testing all the way through launch and operations. The success of Sentinel-6B is presented as proof that when different space agencies align behind a common goal, they can deliver the kind of precise, long-term climate data needed to protect oceans and coastal societies, though some might argue that political will, not data, is now the real bottleneck. Beyond climate, everyday ocean forecasting. Sentinel-6 is not only about long-term climate curves, it also supports day-to-day operational ocean services that people rely on more than they realize. By providing measurements of significant wave height and wind speed over the oceans, the mission feeds near-real-time ocean forecasts used for shipping routes, offshore operations, marine safety, and even some weather models. How the altimeter actually works. At the heart of Sentinel-6B is a radar altimeter, an instrument that sends short radar pulses toward Earth's surface and measures the time it takes for the signal to bounce back. When these travel times are combined with extremely accurate information about the satellite's position in orbit, scientists can calculate the height of the sea surface relative to a reference, producing maps of sea level variations around the globe. Correcting for atmospheric noise. The instrument suite also includes an advanced microwave radiometer supplied by NASA, which monitors the amount of water vapor in the atmosphere along the radar signal's path. Because moisture in the air slightly slows the radar pulses, the radiometer data allow scientists to correct for this effect so that the final sea surface height values remain highly accurate rather than being distorted by changing weather conditions. Early operations and what comes next. Right now, Sentinel-6B is being carefully checked out and configured by ESA's mission control team in Germany during the so-called launch and early orbit phase, a critical period when engineers verify that all systems are healthy and instruments are behaving as expected. Once these checks are complete and the satellite is fully commissioned, operational control will pass to Eumetsat, which will manage routine operations and distribute the mission's data products to scientists, agencies, and service providers worldwide. A question for you. Some experts see Sentinel-6B as yet another warning light on the climate dashboard, while others worry that even perfect data will not automatically lead to stronger policies or faster action. Do you think missions like Sentinel-6B will actually change how governments and industries respond to sea level rise, or are we just getting better at measuring a problem we still hesitate to solve? Where do you stand on this in the comments?